Hey everyone, in today's video we're going to be exploiting a time of check, time of use bug via some DNS rebinding. If you haven't heard of DNS rebinding before, it's an attack where you have a DNS record, a domain that's pointing to one IP address, and the computer system or a web browser will query that domain and see its value, and then later you can quickly switch it to a different value so that the computer or the program thinks that it's connecting to one service, but it's actually connecting to a different service. So we're going to be using that to steal the flag from this challenge. The challenge is webwebhookhook. It was part of IrisCTF a couple weeks ago. It's one of my favorite CTFs. And it was written by Sera, who's again one of my favorite challenge authors. So for this challenge, we're given a download tar file. In the tar file, there's some Kotlin code. Kotlin, it's one of those languages that runs on top of the JVM, similar to like Groovy or Scala. So you can use the Java libraries. But we're given a web server, and it's a very small application. There's only 3 different files. The high level, what this application does is it's kind of like a webhook forwarder. So you send it webhooks, and then it'll forward those webhooks somewhere. And when you register a new webhook, you can give it a body. And so for this challenge, it's going to register an initial, like one of those webhook forwarding things, such that if you send it the webhook of example.com, it'll forward it to example.com, but it'll also include the flag. So somehow we send this thing a webhook. We say the webhook is supposed to go to example.com, and it will forward it to example.com, and it's pre-registered with the flag. And so the way it works in the webhook function, so this is like the main meat of the challenge. This is just a Spring framework. So if you post to webhook with a webhook string, so this is just the URL, it'll search through all the registered webhooks, and if it sees that the URL is equal to one of the registered webhooks, it'll take that pre-saved payload, it'll do a little replacement with the data, and it'll send it off. So the issue for us, we want to grab the flag, but it's only going to send the flag to example.com/admin, and obviously we do not have access to example.com. And like I said, what I like about this challenge is it seems like very sensible code. It's just going to go through all the registered previously known URLs, see if they're equal, and if it is, send it. And so because there's no way we can impersonate example.com, this seems pretty impossible. So my first guess was wrong. I was thinking maybe at first that maybe you could supply a URL like example.com, webhook.com/admin, something like this, where maybe how URLs are, does this equal? Maybe URL equality is tested by just like the first domain in like a weird domain list, or there's like a parsing issue or something like that. And when it eventually makes the web request, it'll go to webhook.com instead. So maybe this equality doesn't quite work like we think it does. And it turns out that is the case. The equality doesn't work as one might assume, but it's not this issue. So if we look at the Java docs for URL.Equals, there's a very interesting sentence here. 2 hosts are considered equivalent if both host names can be resolved into the same IP address or addresses. So that's interesting. So that means Java URL.Equals is doing DNS lookups when you pass it host names to see if they're equivalent. So if you have A.com and B.com, they could be equivalent as long as they resolve to the same IP address. So very interesting. If you search more about this issue online, there's a lot of hate towards this decision for URL.Equals to do DNS lookups. I think in hindsight 2020, yeah, probably not the right decision. But I think if we take ourselves and put ourselves into the shoes, of 20 years ago, there's this interesting article or spec, URIs, URLs, and URNs, classifications and recommendations 1.0 from 2001. So it's an older article. But if we think of like philosophically what a URL was supposed to be, a URL is different now, but a URL was supposed to be a location, a uniform resource location. And so if you're comparing 2 locations, it kind of makes sense that even if it has different host names and they point to the same location, the IP address, why wouldn't they be the same? I think as time has gone, 20 years has passed since this moment. And now that things have, evolved, now the URL is also the URI. It is the identity, the identifier. It doesn't make sense, and there's a whole bunch of issues related to this, which we'll talk about in a second, but I feel like they don't deserve too much hate for this decision. I feel like it's just not, it wasn't a terrible decision at the time. I feel like more than the security or all the philosophical stuff, I feel like just the performance hit of you wouldn't expect an equals to do a DNS query? Like what if the DNS is down or there's just a delay or you have spotty Wi-Fi? So there's a entry in the Java bug database for this issue back from like 2001 or something like that. Yeah, 2001. And I like the related reports. The first one is JavaNet URL.Equals behavior is wrong for virtual host, which is, interesting, and that makes sense. So for a virtual host, you can host multiple websites on the same server. And this is common, like if you do like PHP and Apache and stuff like that, like you can specify literally virtual host and you can host multiple websites. And so when the website receives a request, it doesn't know which web server the request is for until it looks at the host header in HTTP or the SNI server name indication within the TLS certificate to know which content it should be serving for. And this just reduces costs. Like if you have like 20 minor websites, you could just have one EC2 and do virtual hosting. So whenever they send the host header or, the SNI field, you can just serve for that application, which makes sense. But it also, even outside of just like, your own little virtual hosting, the big like platform as a service companies like Cloudflare, for example, they host many applications that resolve to the same IP address. And again, they're using, the host name or SNI or something like that. But should every single Cloudflare application be equal? Definitely not. Again, like I don't think the Java developers should get too much hate. Like who knew that virtual hosting was going to be such an important thing? Like maybe it was at the time. Again, I wasn't programming in 2001, but that is interesting. Another one is it takes 20 seconds to get hash code of a single URL. And so yeah, a hash code is for one of the things you can do with it is for equivalence. And so, of course, if the DNS record takes a long time, it's going to take a long time to get hash code. And so another thing, when you use Java maps, like a hash map, the key is usually the hash code. And so because of that, if you're going to put URLs into a hash map, it's going to be very slow. So a lot of just fun little things. So now that we have a little bug to play with, we need to figure out how we can use it. And so what we can do, so this was the web request. So again, when you send a hook string, so this is a URL to webhook, it'll go through all of its known previously registered webhooks. And if it's one it's seen, it'll send off the payload and one of them can include the flag. So what we're going to do is we're going to send a webhook. We'll say hook is equal to evil, we'll do evil.com. So what we want is evil.com, when it's doing this equal, it's going to do a DNS lookup on evil.com, and we want evil.com to resolve to the DNS of example.com. Cool, and you can do this. There's nothing stopping you from registering, pointing a domain at any IP address you want. Cool, and so then later, when it comes down here, it's going to do hook.openConnection, and so this is going to start that HTTP connection. We now want the DNS to resolve to something different, and so now we want evil.com, the DNS of, our endpoint. So we'll say 1, 2, 3, 4. Oops, 1, 2, 1, 2, 3, 4. So now when it makes this DNS check, it'll be the DNS of our endpoint, and so it'll actually send it to evil.com or whatever our endpoint is. And so really the exploit is just doing a quick swap from evil.com resolving to example.com or the IP address of example.com, and then later evil.com resolving to 1, 2, 3, 4 or wherever we're going to have our netcat listener. And that's pretty much the challenge. So there's a couple of different implementation details we have to think about. The first is DNS caching. So DNS caching happens at many different levels. Java has its own DNS caching. Your operating system most likely has DNS caching. The browser isn't part of this, but browsers have their own DNS caching. You might have DNS servers on your network that are also doing the caching. There can be different levels of resolvers that are also caching. So because of that, it makes this a little bit tricky in that from here to here, when we want the two resolutions to change, there's not much happening. This is a very narrow window. An if statement and a little template replace. We're talking very few JVM bytecodes. And we also, as doing this challenge, you'll find out that the Java itself is caching DNS entries and it caches them for 30 seconds. So technically, this is not doing a separate DNS lookup on first executions. It's going to resolve it to example.com and then it's going to continue. It's not going to look at the DNS entry. It's just going to send it to that IP address of example.com. So the way we're going to bypass that is we're going to send two different requests. We're going to send a request at t=0. It's going to cache the first DNS lookup, and so that'll go to example.com. We're then going to wait 29 seconds. We're going to send another request. It'll still be in the cache, and we're hoping that this happens at 29.99 seconds. This check will still happen with evil.com being in the cache for example.com. And then we hope that in between here, the cache will expire and it'll do a new DNS lookup at this point. So it is a very narrow race and we're going to get it wrong many times. There's a couple different tricks we'll talk about that other people did. I did the very lazy ways. I just, fire and forget. But there are some clever things that you can do to make it a little bit more reliable. So my solve script for this, again, I did it the dumb way because I'm lazy. So this was the challenge. I think they were using Instancer, so this was my unique challenge. This was the IP address of example.com. One thing that's fun is, oops, not that. When the challenge was live, there was only a single A record for example.com. And since then, it has now changed, and now they're doing round robin, and there are 6 A records. So I think this attack would be much harder to do now compared to 3 or 2 weeks ago, whenever the CTF was, which makes it fun. So I think I can't really show it. We could switch out example.com, but I don't think it matters too much. I then set up a little droplet. So this was my droplet's IP address. For doing the rebinding, there's a couple different ways you can do it. I use a service called Rebinder. This is the service I use. There's a couple other online services, but basically all the service does is you type in 2 IP addresses, and it'll resolve between these 2. So we can take a quick look at this. So if we do dig, oops, let me do a reset, dig this, it is now returning 127 with a TTL of 10. So now we're waiting, TTL time to live, we're waiting for it to expire. 3, 2, 1, and now we reset it, and 10. Oh, it does it randomly. We got, well, I guess lucky or unlucky. It went back to 127,001. So we're waiting for this value over here to change. 2, 1, and now it is switched. And so now we have to wait another 8 or 10 seconds, and you can see 192.168.001. So this DNS record this tool will allow us to switch between 2 different IP addresses, and it just randomly picks one. We can see we have this TTL of 10. I think that's actually done by my computer. So if we can dig, we're asking for that. We can actually specify our own DNS our own DNS server that we want to use. So if we do 1111, I think this is Cloudflare. Cloudflare will tell us it has a TTL of just 1, and it's resolving to 2020 to this entry. And you can see it switches back and forth much faster. So I'm guessing it's my system somewhere, maybe Ubuntu by default caches things for 10 seconds. I don't know. You can also ask Google. So 1.1.11 is the name server for Cloudflare. 8888 is a DNS server for Google. And we can see it is also doing a TTL of 1. I was hoping I could ask the authoritative server for Rebinder.us how long the TTL was for the actual record. Maybe someone can help me out. I don't understand why I can't ask this Rebinder.us for its start of authority or its name server. Like, these should tell us, we should be able to get a authoritative response from one of these, but neither of those has a start of authority or name server. My intuition says that they should. I'm not really sure what I'm doing wrong. If you use an online tool and you ask, do a DNS lookup on this, it'll tell me that this was the reply server. And so then we can ask this DNS, this, actually, let me go back up. So now we can get more of an authoritative answer, but I'm still curious as to why that didn't work. So if you have any ideas, please let me know, or if there's a better way to ask for the authority of a domain. Anyways, back to the solution. So we have this DNS entry, and it'll resolve between example.com and a droplet I control that just has a netcat listening on it. And like I said, it'll just switch back and forth. And so at this point, you could be smart or you could be dumb like me, and you can just, spam a bunch of requests and hope you get lucky. This solve script took about 20 minutes using this dumb solution. And the dumb solution is I just put it in a while loop and I just requested a whole bunch. You can see I'm just sending in that Rebinder domain as the hook. I put this in here just in case. I don't think it's necessary, but just in case the flag, it was doing like that little replace thing. Maybe it's necessary. And eventually you just get lucky on that 30-second cache eviction, and you'll hit that, be right in between when it expires, and then you request a new one, and the new one is the good address or your attacker address. And eventually it works. I just put it inside 10 threads and let it run. So I looked at the other write-ups to see if they were using any other neat tricks. Probably my favorite write-up was, again, by the challenge author, Serafin. They used a service called Singularity. It was written by NCC Group, a pen testing company out of New York City. We used to use them at a previous company. And so they have the Singularity service. They did a whole bunch of research. They have I think it was a DEF CON talk. I'll link it below. It was a good talk. They built this service called Singularity, and there's also a public instance of it. I don't know if it's like public to use, but it's live and people can use it. And it just has a lot more, features. It's like a full built out sort of service. So you can, kind of similar to that rebinding one we used. You can define the two IP addresses. You can give them sessions. And so if you are using a particular strategy, each one of these will do like on off as unique to their session ID. So you can run the attack multiple times at once. And then you can also define different rebinding strategies. So first, then second, multiple answers, round robin, random. So if you want to do like rebinding in the wild for good, I hope, I feel like this is the tool to use. And they also, Seraphim also did something to make the exploit more reliable. They know that the cache is going to last. The Java DNS cache is about 30 seconds. So you don't need a spam request for those 30 seconds like my dumb solution. You can just wait, 30 minus a couple of seconds and then send the next request. I should have done this too, but again, I'm dumb and lazy. So yeah, if you just wait until the right amount of time, you can kind of like narrow down that window and you're not sending, a bunch of duplicate requests. And if you get really good with your timing, it should, Seraphim says they get it in like 3 requests or something like that. The solution works every 2 to 3 attempts, which is pretty cool. Some of the other solutions, 2 of the solutions actually ended up doing their own DNS server. So this is a write-up by Zimzi. And if we look at their implementation, they said this code is fully written by ChatGPT, so it works for CTFs. But it's just a little Python server, and it'll serve the 2 IP addresses. So if you needed something custom for a CTF, you can get it here. I'll put all the links in the description. But again, it's just a little DNS server that responds. And so I guess the way this would work is you spin up an EC2 or a droplet or something like that, and you would point the NS record for that particular domain to this EC2 and make sure all your firewall rules are open. And then this will be your authoritative source, I guess. So another write-up, this one was by Jorian Walcher. Again, they also did a little Python server. This was their script, and so again, they're just kind of iterating between the 2 IP addresses. And then the final write-up I found was by Tom Dimitri. Again, all the URLs will be in the description, and they also use the same service, the lock.compare exchange. This service is run by Travis Ormady, a famous bug hunter at Google. If you're a blue teamer or you're actually responsible for the security or giving advice on the security of products, if you're curious about how you could fix this, Java recommends, as part of that Java bug database issue, they recommend using the URI_equals instead of the URL_Equals. And the URI_equals will do a more kind of expected string compare. But yeah, fun issue, great challenge, a great CTF. And I'll see you at the next one. Cheers.